Hello friends, welcome. Today, let's talk about something that can truly change your coding journey, data structures and algorithms, or DSA. Many of you ask, why am I stuck? Why can't I get a job? The answer is often simple. You need a strong foundation in DSA. DSA is the language computers understand. It's how you turn code into real solutions. Learning a programming language is great, but DSA teaches you how to think, organize, and solve problems efficiently. It's the difference between being a coder and becoming a true software engineer. Top companies like Google and Amazon look for this skill. Think of DSA as the foundation of a skyscraper. Without it, your code will collapse under pressure. That's why interviews focus on how you approach problems, not just writing code. Are you ready to build that strong foundation? Let's make these concepts simple. Asan hai. This isn't about memorizing theory. It's about understanding logic and patterns. Today, we'll demystify DSA and make it easy for you. This is your first step to becoming a master problem solver. Let's begin this journey with the data key and unlock endless possibilities. Asan hai. Why do data structures matter? Imagine a library with thousands of books thrown in a pile. Finding one would be chaos. Data structures organize information, making it easy and fast to access. They're like shelves and catalogs in your digital world. Each structure serves a different purpose. Some are for quick access, others for complex relationships. Your phone's contact list is a simple data structure, organized for fast searching. Every app you use, from Instagram to Google Maps, relies on these principles. Learning DSA means understanding how modern technology works. It's not just theory, it's the secret behind building real, efficient applications. That's the true power of being a programmer. Let's start with the array, the simplest data structure. Think of it as an egg carton. Each slot holds one item, and you know exactly where each is. Arrays are great for fast access when you know the size in advance. But arrays are rigid. If you need more space, you have to create a new one and move everything. Enter the linked list. Imagine a train where you can add or remove coaches easily. Each element points to the next, allowing flexibility to grow or shrink. Linked lists are perfect when you don't know how many items you'll need. The trade-off? Access is slower. You have to walk through each coach to reach your destination. So, arrays offer fast access, while linked lists offer easy modification. Choose based on your needs, speed, or flexibility. Arrays and linked lists are the building blocks for more complex structures. Understanding them is key to managing data efficiently. Every app, from playlists to calendars, uses these ideas. Master these, and you're on your way to pro-level coding. Asan hai. Now let's talk about stacks and queues, two structures you use every day. A stack is like a pile of plates, last in, first out, LIFO. Undo actions in software use stacks. Each action is stacked, and you undo the most recent one. A queue is like a line for a bus, first in, first out, FIFO. Printers and customer service calls use queues, first request, first served. Stacks are for reversing things. Queues are for processing in order. Both are simple but powerful tools for managing tasks. They keep your programs organized and efficient. Understanding when to use each is crucial for real-world coding. Stacks and queues are everywhere, from browsers to operating systems. Master them, and you'll handle tasks like a pro. These concepts are the backbone of many algorithms. Simple, right? Asan hai. Let's move to a powerful structure, the tree. Picture a family tree or your computer's folder system. Both are hierarchies. A tree starts with a root and branches out to children, then grandchildren, and so on. Trees are perfect for representing relationships and organizing data logically. The binary search tree, BST, is a special kind. Each node has up to 2 children, with smaller values on the left and larger on the right. This rule makes searching lightning fast. You eliminate half the data at each step. Databases and search engines use tree structures for quick lookups. Trees allow for efficient searching, sorting, and organization. They might seem complex, but they're just a natural way to manage hierarchy. Mastering trees is a big leap toward advanced coding. They're everywhere, from file systems to AI. Understanding trees unlocks new levels of problem solving. Aasan hai. Now, let's talk about algorithms and how we measure their efficiency. Big O notation. Big O describes how your code's performance grows as data increases. For example, searching a phone book one by one is ON, linear time. But if the book is sorted, you can use binary search. Open to the middle, cut the search space in half each time. O log n, much faster. Big O isn't about exact speed, but about how performance scales. ON is good. O log n is better. ON2 is slow for big data. It helps you compare solutions and pick the best one. Understanding Big O makes you a smarter programmer. It's the language of efficiency in coding interviews. Always think about how your code will perform as data grows. Big O is your tool for writing scalable professional code. It's simple once you see the patterns. Aasan hai. Let's dive into searching, finding data in a collection. 2 must-know algorithms: linear search and binary search. Linear search checks each item one by one, works on any list but can be slow, ON. Binary search is much faster, O log n, but only works on sorted lists. It divides the list in half each time, quickly zeroing in on the target. For 1 million items, linear search could take 1 million steps. Binary search, just about 20. The difference is huge for big data. Knowing when to use each is key. Searching is everywhere, from finding contacts to searching Google. Master these basics, and you'll handle data like a pro. Efficient searching saves time and resources. It's a core skill for every developer. Aasan hai. Sorting is about organizing data for easy access. Without sorting, fast searches like binary search aren't possible. Bubble sort is simple. Compare and swap adjacent items until sorted. Easy, but slow. ON2. Merge sort is smarter. Divide the list, sort each part, then merge. Much faster. ON log n. For big data, merge sort is a game changer. Sorting is everywhere, from leaderboards to search results. Understanding different sorting strategies is key to writing efficient code. Choose the right algorithm for the job. Sorting and searching go hand in hand. Master them, and you're coding at a professional level. Today, you've learned how data structures organize information and algorithms solve problems. Big O helps you measure and improve your solutions. These aren't just academic, they're the skills top companies want. Interviews test your problem solving and your ability to choose the right tools. Mastering DSA is your path to becoming a confident, in-demand developer. Every problem you solve builds your skills and confidence. The struggle means you're growing. Embrace it. The satisfaction of solving tough problems is priceless. This is just the beginning. There's a universe of concepts ahead. My goal with the data key is to make every concept simple and relatable. You have the potential to master this. Believe in yourself. Start learning, keep practicing, and never give up. Your dream job and career are within reach. All you have to do is turn the key. Aasan hai.